I'm really excited. This is Ben at Calyptix. Excited about this program that Dwayne and Warren have put together in response to quite a number of questions, support cases, and experiences they've had. And as we've grown and added new partners and new techs have joined old partners. So I think this will be great content for you guys. We'll look forward to your feedback and suggestions. Also wanted to share with you guys how excited we are about the recent release of 5.0.3. That version includes the Community Shield, which is the long-awaited automated information sharing platform where we are blocking attacks inbound and outbound with identified bad IP addresses from our own community. We're seeing a lot of great positive results. Our analyst team is working on adding more feeds. We are also publicizing the external threat feeds that are incorporated in the solution, which include thousands of IP addresses known to harbor malware. And so we're working on, in the next phase, providing notifications to you in a good, concise summary format with some enhanced threat intelligence, so you'll be able to dissect those scenarios if they happen at your sites. We've also in 5.0.3 added the LDAP integration for Gatekeeper, so it's now extensible to third-party LDAP systems beyond Active Directory or the box itself. So if you use Jump Cloud, Google's directory service, or something like a NAS device that has an LDAP server, you can use those for a user base as well. So those are just a couple of recent announcements in the queue. We are also working on some exciting new features, including 2FA multi-factor for both the VPN as well as the GUI, as well as SSH. That is in testing now. And so as that gets completed, please be on the lookout for that alert. That will be an opt-in feature. So again, we thank you for your support. Look forward to your feedback and suggestions, and excited for Dwayne and Warren to kick this off today. Thanks, guys.
Good afternoon. Wanted to thank you for coming to the Packet Analyzer. We're going to go over some configurations and troubleshooting. At present, my name is Dwayne Pettis.
And my name is Warren Parker.
And we're going to be doing this training for you. But before we begin the training, I did want to mention two other people we've added to Calyptix. Calyptix is growing over here. And I did want to mention that we do have new people. So we have Joseph Schmitz. He's here. And he actually helped in this presentation as well. And he is our marketing and sales associate. Joseph, can you say hey?
Hello.
We also have India Thomas. She is our cybersecurity developer, and you will probably be hearing a lot from her a little bit later on, not in this presentation, but you'll be hearing from her because, as Ben said, we are noticing a lot more threats with our Community Shield, and she is in charge of that project as well. So we did want to say, to introduce both of them. India, can you say hello? So we are growing over here at Calyptix, and we're thankful for people to come out to our presentations, and not only our presentations, but to come and help us, help you guys be more secure. So let's get into this Packet Analyzer training that we have.
So before we begin that, we just want to show you this new site that we've got for site name changes. So whenever you deploy or move a unit from one company to another, you can use this helpful form to register that name change so that everything on the my.calyptix.com lines up with your expectations.
Great. Now, for our agenda, what we're going to go over is the Packet Analyzer, how to solve some problems. We're going to go over the common words that we use and common phrases, the combinations, and then we're going to do some live demos at the end. So strap in, prepare, and for most of the people, when we go on your box, Warren and I, and we're trying to diagnose a problem, generally we're going to go to the Packet Analyzer to find out where the traffic is and how we can figure out this and segment where the traffic is going. So let's get started with the presentation.
So what is a Packet Analyzer? So first let's talk about what a packet is. A packet is a datagram of information that when assembled comprises a larger file. It's the unit of measure for when you're sending traffic across any network, whether you're local or across the internet. And to be able to view these packets as they're crossing an interface is a very helpful diagnostic tool to have. It allows you to identify security threats. You can troubleshoot certain types of behavior to make sure the mail is flowing, to make sure that your MX record is getting hit correctly. It lets you see network congestion. So you can see if there's a bad actor behind the firewall taking up all the bandwidth. That'll be immediately noticeable in the packet capture. You can also see when packets are failing to get transferred, another helpful diagnostic thing. And you can also perform forensic network analysis. So if you wanted to see where a potentially compromised machine is communicating, then a packet analyzer session is just what you need. So, you know, when you do a packet capture, there's a tremendous amount of info that you can potentially see. Now, it's really helpful to be able to limit those filters to be able to see only specific things. These commands over here on the right, hosts, net, so forth, these help you do that. If you only want to see one host's traffic, if you only want to see some of a certain net or a certain port, like for example, if you wanted to troubleshoot Calyptix VPN, you could do a port 1194 session on the WAN to see if traffic is actually hitting the WAN. Very helpful thing to do. You can also limit to ICMPs on the WAN and the LAN, ARP, and of course, Ipsec Traffic as well. Now, the most common device endpoints are here displayed. IP address. If you want to see a MAC address, you can do that as well. You can also see host names too. We also have operators, so you can string together these and or not commands to further draw down on whatever you're trying to investigate. Now, we can do packet captures on every interface of a Calyptix. So, for example, here in this image, we have the WAN. We have a few VLANs that have NIC1 as the parent interface. So we can do a packet capture on the NIC. We can also separate out and just do the packet capture on each individual VLAN. We're also capable of doing it on IPsec VPN interface, Calyptix VPN, the firewall log, which shows blocked traffic outbound, and the gatekeeper and geofence log as well. Those supplement the network alerts page, which is the typical place you're going to see those. To help you understand, here's a visual representation of all the different networks, the physical ones, NIC1, NIC2, and NIC3, and the virtual ones. So in this way, a VLAN, a static route, an IPsec, or a Calyptix VPN act very much like regular networks. So it's easy to break down each of these interfaces to see what exactly is happening.
Thanks for that, Warren. Now, we're going to just go into why you guys came. We want to find out how to use a packet analyzer to break down your network. We're going to find out, you know, basically, is it Calyptix fault? Is it the internal network? Is it the switch? Is it the modem? Is it the ISP? Is it something else? We're going to try to help you figure this information out. So with the next slide, we can see it's broken down into different sections when dealing with the Calyptix. You have your internal network, which is in the green, and some issues may be caused by that itself, our device itself, which ties everything together, which is why a lot of times when you reboot the Calyptix, it may not be a Calyptix issue, but when you reboot the Calyptix, because it's in between your switch and the rest of your network and the modem, it may result in fixing the problem. So a lot of times people call and they say, hey, I rebooted the Calyptix. What was the problem? But actually the problem was with the modem, but resetting that actually helped out that process. So let's go ahead and look at how to do this. But before we start, I did want to give you a Calyptix tip. It's what we call 4 corners minus T. And this is probably one of the most helpful things you could do internally on your network. Somebody complains, hey, we're having an issue and our network is really slow. The reason it's called 4 corners minus T is because we're going to open up 4 command prompts on a machine. The command prompt to the left top will be, we're going to ping the internal gateway of the Calyptix. The one below that, we're going to ping the external gateways of the WAN side of the device. Then we're going to ping the modem gateway, and then we're going to ping Google's DNS server. With these pings, we're going to add the prompt -T, what's that called? The -T to make sure that it's a continuous ping. So once you do this, eventually one or all of these windows will start to have problems. And when we say have problems, either they will go to a request timeout or they will increase in number so much so that we can figure out what's going on. If by some chance, let's say, for example, you see that the internal gateway is still at less than 1 millisecond, if we see that the Calyptix internal and external gateways are still at less than 1 millisecond, but the modem has started to move up to 800, 900 milliseconds, then chances are your problem is with your modem or with something above us that's having issues. So a lot of times this screen right here can break down how we segment our network. Warren, can you go back one screen? So looking at our screens here, in our greens, our purples, our blues, our browns, we can even see how the network is broken down. But with those four corners -T, it will tell us at a short distance where the issue might be.
So first, we're going to start out with a very simple test. We're going to open the packet analyzer, and we're going to show you how much traffic you can see on the WAN. Then we're going to open it up on the NIC1 interface and see what we can see right there. So I will bust out of the PowerPoint. And here we are live on a demo unit. So this is the main system status screen. You've all seen this. This is the landing page when you first log in. Here on the left-hand menu, Diagnostics, we're going to open up a new tab, and we're going to be using this to do our packet capture. So selecting the WAN interface, we're just going to hit start. The default packet count is 1,000. That's typically sufficient, but boom. Let's see what we can see. So as you can see, there's a lot of traffic happening on the WAN. You can tell by the bar over here just how much there is, and it refreshes every few moments. Let me just take a quick note to say that you can, we prefer to use our interface here to kind of do most of our troubleshooting, but there are times when we need a little more statistical analysis. So what we can do is click on the download TCP dump file, and we can actually download this, open it in a program called Wireshark, which is a very, very helpful utility to really kind of find out more specific info than just a text screen could provide. We're not going to go over Wireshark. There are plenty of repositories for good information on Wireshark on the internet. You can email Calyptix support. We'd be happy to provide some for you, and on YouTube as well. Okay, so one thing we will do after we finish each trace is kill it. So we're going to go ahead and kill this trace on the WAN, and we're going to open it up on NIC1 to see what we can see there. Now, this is a good time to remind you that if you are veterans at doing TCP dumps and doing packet captures, this might not be for you. We're trying to introduce this feature and ability to people who maybe have heard of it but don't know exactly what it's all about. That's who we're kind of targeting for these. Now, here's the LAN side. So here we see all private IP addresses, some traffic, 8006 traffic I can see, but that's all normal. This is what you typically see on a LAN interface. So now we've seen it, we're going to kill it.
All right, so the next thing that we want to do is we want to look for some Icmp traffic. Generally, this is the most common traffic because with a ping test, we can just see if things are going to be responding to us and if they're there. So in this ping test, we're going to ping a couple things just so you can see what they look like on the Calyptix. So we're going to open up our live demo again.
We did mean to do IMCP. We wanted to do a mistake that everyone could see. So we say, hey, we made one mistake.
So from here, the first thing we're going to do is go to our home screen, and we're going to show our networks. So you can see our networks down at the bottom. And on this device that we have a 192.168.21 network and our WAN network. For now, we're going to be working on our 192.168.21 network, which is our NIC1. This is how we can tell what we are going to be working on. So if we open up our diagnostics under Home, Diagnostics, and we're going to go down to our packet analyzer, we are going to capture packets on our LAN side, which is NIC1. And we're just going to put in ICMP, which is ping. And we're going to click start. Warren is going to move over one of our standard VMs that we have. And we're going to use the main for this one. And we could do an IP config just to see. And when we do an IP config, we see that we are 192.168.21.107. So that's the traffic we're going to try to ping. So at first, we're going to ping our outside WAN gateway, which is the 108.94. And we see that this ping responds with a reply. Now, when we go back to our packet capture, we will see that 192.168.21.107, which was our main machine, was pinging the .94, and it responds back and forth on our LAN. Now, generally, you want to see both traffic on the LAN and WAN side. So what I'm going to ask is that Warren open up a second packet capture. And under that second packet capture, this time we're going to capture packets on our WAN side for ICMP. And we're going to hit start on that one as well. Then when we bring back our VM, main 21, which is the 107, Warren is going to ping again to the outside gateway. And then we'll go back to our main configuration on the AE. And you'll see that it is on the WAN side. And this time it's reporting on the 108.212, which is the WAN IP address. So you know that's on the WAN side. So if you go back to the other tab, it'll show the local IP address, which is the 192.168.21.107. So this, we can see that this traffic is passing through the Calyptix device from the LAN side to the WAN side to make sure everything is working. And we want to kill our traces after we finish. Thank you.
Okay, so one of the most common things that we troubleshoot is going to be Rdp traffic, usually happening from one interface to another, and that's the test that we're going to recreate right here. So we're going to have one computer trying to Rdp to another one on a different network. So this is being routed through the AccessEnforcer from NIC1 to NIC2. We're going to see what we can see when we do that. Okay. So we're going to bring up our VM right here, and we're going to just make sure we can see ipconfig, and we're from 172.16.42.18. Now here's our other computer. Its IP address is the same, 192.168.21.106. So we're going to come back, and we're going to initiate before we do this, though, I don't want to get too fast here. We want to come over here to NIC1, and do the default port for RDP, which is 3389. And we're going to do the same thing on NIC2, port 3389. All right. So here we are back on this one. We're going to open up our RDP session, and it's pre-populated with the address 21.106. We're going to hit connect. We're going to come back to our packet captures while that's happening. And we see, oh, one-way traffic. We were neither successful in connecting where'd it go? There we go. So our 3389 port RDP attempt was no good. We didn't get through. I should have left it up there so you can see it. But we all know what that looks like when it fails. Now we're going to come over here to the target machine that we were trying to RDP to, and we're going to make a change. We're going to actually allow Rdp traffic using the Windows firewall through private networks. So we're going to come down here, find remote desktop, and enable it for private. Then we're going to hit OK, save that change. Now we're going to come back, and we're going to try again. We're going to try to hit the 21.106. And this time, we're actually successful in getting logon screen. When we come back to our packet capture, this one-way traffic has now become two-way traffic. So for the destination computer, the source's IP address, the 172.16.42 network, is considered public, or it's not, well, it didn't allow it through the Windows firewall because it wasn't allowing that through private networks. Looking over here to NIC 1, it's also successful. So that's one of the main things we do. Tell people to turn off your Windows firewall just temporarily to see if that restores connectivity, or more appropriately, we simply just let that traffic through the Windows firewall and it's successful. Now that we're done, we're going to kill both traces. And continue.
So one of the most common things we have seen with people opening up RDP was what Warren suggested. We see one-way traffic, and when we get on your box, the main thing that we're looking for is to see if we see one-way or two-way traffic. So that one is very, very important. Now we're going to move on to our IPsec traffic. So IPsec is a tunnel between devices. So what we're going to do is we're going to try to break down and show that on the Calyptix device, unlike a lot of other devices, we can actually show encapsulated traffic before it gets encapsulated. So we'll see that traffic before it's encrypted so that you can see and troubleshoot and see if that's inside of your tunnel. Then once we see that traffic, we're going to try to narrow down to one or two specific tunnels so that we can see that traffic as well. So we're going to go get prepared for this live demo so that you can see this as well. So the first thing that we're going to do is we are going to show the main home screen because we want to show that there is more than one tunnel. So if we go back to home and scroll down, you'll see that we have more than one tunnel on this box, which means we'll probably see more traffic than we want to see when we go to our presentation. So on the next screen that we have over here, we are going to just go to home diagnostics, the packet analyzer. Then we're going to capture packets, but this time we're going to capture them on the IPsec VPN tunnel. So in capturing packets on the IPsec VPN, we see, as Warren starts, lots and lots of encapsulated packets. So this is the traffic between two IPsec tunnels. There's a 192.168.21 device, and you'll see that it's talking to a 53 device, which is not one of our networks that we have on our local machine. So this is actually over the IPsec tunnel. So unfortunately, it's not the traffic that I want to watch. I want to watch the traffic that's coming from another location. So the first thing I would do is I would open up a Calyptix. I would go to Setup, VPN, and then on the IPsec setup page, I want to copy the public peer IP address that I'm looking for. So I'll copy that information. Then I'll go back to my packet capture. And for the BPF syntax, I'll put in the word host, put a space, and then I will copy that IP address. Now, this is the traffic that I want to see. And as we saw before, there was 192.168.53 traffic. I want to see traffic on the 10 dots. So let's see if we can narrow that down. So now we'll see traffic on the 10.0.2 network, which is another network, and that's the network I wanted to find that traffic to see if it was going. So if you have multiple IPsec tunnels on your network and you want to narrow them down, you can put in the peer IP address of the remote side, and it will just show you packets for that IPsec tunnel. Thank you, Bryce.
Okay, so for this test, we are going to use the IP of a local machine, and they're going to be going to a certain website. So we're going to see traffic as it passes, and then we're going to look on the WAN to determine the IP address that might be associated with it.
And the first thing that we are going to do is we are going to go back to home on our, and we're going to show under home when we scroll down. We're going to be dealing with the NIC 1, I believe, because we're going to be on the 192.168.21 network. So that's also just our NIC 1. So if we open up our machine that we're going to demo on, and we'll open up main 21, and we'll see that main 21's IP address is 192.168.21.107. Good. So the first thing that we want to do is find out, okay, 21.107. So when we go to our packet analyzer. We're going to capture packets on NIC 1, and we're going to narrow it down to host space 192.168.21.107, and we're going to do end port 443 because I only want to see 443 traffic. I don't want to see any other traffic. So we click start. And now when we open up our main 21, we are going to open up a browser. And when we go and refresh Google, it should show Google's information as it's on this capture. So if Warren scrolls down and we see 8.8.4.4, and then we scroll down, we say, oh, Google's IP address is 64.233.177.91. So now what we want to do is open up another capture on the WAN side, put in the host and that IP address. And Google is a weird one because it may switch IPs, but we're going to try it here. And we're going to start that capture. Then we're going to open up main 21 again, our main box, and we're going to refresh. And we should see Google's information on the 108.212, which is our public IP address. So that's a good way of finding out how from the LAN side, we can find out the WAN side IP address. So we use the LAN side to find out where that machine is going, and then we put it on the WAN side to make sure that we get back and forth traffic. So it is passing through the Calyptix.
So here we can also do a packet capture, and we can do so for certain hosts. So it's very simple. The interface will do a DNS lookup for any domain that we want to use. For our example, we're going to use www.calyptix.com. And then we're going to see what happens when we try to look up a domain that doesn't exist, which is the accessinfo.org. So here in the WAN, we want to do host www.calyptix.com, and then over here on our computer, our virtual machine, we're just going to go there. But after we start the test first, of course. Oh. Well, there we go. Problem solved. Here we can see all the traffic associated with that IP address. So it's very helpful to be able to troubleshoot when you're looking for a specific domain rather than having to constantly switch back and ping it or look up the IP address associated with it, when you can just simply put it into the BPF syntax and be able to see it. Now we're going to kill this trace, and we are going to do the www.accessinfo.org. And so we already know that there's no DNS record for this domain, for this FQDN. So the test fails because it failed to look up the IP address associated with it, and you can't do that. So it's a very helpful thing to be able to know immediately if something is not viewable and it fails quickly. Okay, so one of the best operators that we're going to use to be able to trim traffic out of our packet captures is the not command. So BPF syntax, we're going to look at traffic on the WAN. We're not going to actually use that. We're just going to do a straight WAN packet capture and see things that we can see. So let's do that. And we're going to slowly find traffic we want to filter out so that we're getting a smaller and smaller and smaller subset of what we're trying to troubleshoot. All right. So here on the WAN, let's just go ahead and refresh this page so we don't see a big red X. Add a 0 here just to see, and we're just going to start. Now, like we did in the very first test, there's going to be a lot of traffic here. So I'm actually logged into the port 9443 on this public IP. So there's a lot of the traffic associated with the GUI. That's really key to be able to filter that out if you're connected remotely to one of your clients. So we're going to change the BPF syntax and say not port 9443. So that effectively filters out our connection to the firewall externally. And let's see, I can see some Ipsec traffic, which is the ESP. I can also, well, let's just filter that out. So if we want to say not port 9443 and not ESP, which is IPsec. Now, just that little filter right there gets rid of that huge swath of packets that you are going to have to look between and through in order to find the traffic you're actually trying to troubleshoot. So cutting down on what's visible in a packet capture really, really helps. If you have Wireshark, then you have the luxury of being able to import everything into that and use those filters to kind of draw down. But when you're just doing a visual check through the GUI, these operators really, really help cut it down so you can see what makes sense.
That's great. And those are probably, when we're on your devices, that's probably one of the primary things we're doing. We want to see all of your traffic, but we don't want to see our traffic that we're creating being on your device to troubleshoot. So that will help you out. The final one that we're going to go, one of the final ones we're going to go over is the ether host command. Now, the ether host command comes in when you have to look at a MAC address instead of an IP address, because the traffic is not on the router it's not on your router. It's on a router that is behind us or parallel to us. So we want to see if that traffic goes over to another network. So we'll use the MAC address. And the reason we do this is because when you're trying to traverse traffic that is on your network, not on your network, then we have to go by MAC address so that it can cross over networks instead of IP address. So
now note that we will make these this presentation, this PowerPoint, available to you after this this webinar.
So we're going to try and give you all the information that you need for this. So if we could go to the Tangle box first. And this is our Tangle box. So this is an AE that is parallel to the Calyptix. It is on the 192.168.51 network. So we can log into this one. Okay. And as you scroll down to the main homepage under link status, you will see that we have a 192.168.51 network on this one with machines behind that as well. We also have on NIC 5 192.168.21.20. Now, the 21.20 is very important to us because our main Calyptix has a 192.168.21 network. So the thing that we're going to try to do is watch traffic as it's going over the Calyptix so that we can see that 51 traffic. And we're going to try and attempt to do that now. The next thing we want to do is let's go over on this device and we will go to diagnostics. And we want to, we have to find out the IP address. Let's find out how we find out the IP address on our main box. So the first thing we do is we bring up home diagnostics ARP table, and we want to see if that 192.168.21.20 is in there. And it's not. So I'm going to ask Warren to ping 192.168.20.20 from the 21 network and see if it shows up. Now, if you're not passing a lot of traffic, it will drop off of your ARP table. So since we are not passing a lot, we are going to just wake it up so that we can see it there. So now that we've pinged it, if we go back to our ARP table, that IP address should show up on your ARP table now, which it is, and the MAC address associated with the other side of the network that we're trying to accomplish. So we're going to copy that IP address, that MAC address, 192.168.20.20's MAC address, and we're going to open up a packet capture. And this time on the NIC 1, since that's where we're going to be looking, we're going to do a ether host and that MAC address. And we can start that traffic. Now, we are going to go to our main box, which is main 21. And we're going to open up a command prompt. And we are going to ping this time 192.168.51.20. Then we're going to go back to our packet capture once we start that. And you'll see that from the MAC address of that device, you'll see packets are going over that ether host on 192.168.51.20. Now, from this device, our device doesn't know about the 51 network unless we add a static route. So what I'm going to ask Warren to do is show you where the static route is to show it where to go. So if we open up our browser and we go to Setup, Network, Static Routes, you'll see that we've added a static route to the 51 network. So what I'm telling you in this static route is if you go to 192.168.51.anything, I need you to go to the 192.168.21.20, which we saw was the other side of the second router. So all traffic that is on my main network, if I need to send it somewhere else, we're going to open up this static route. And as we can see, we saw the traffic go from our 21 network to our 51 by watching the ether host. So we saw the traffic go over to the other side of the AE, which is parallel to us.
Just a brief reminder, static routes are best used when you have a network that you want the AccessEnforcer to know about, but which you don't have an IP address for. That's a static route.
Thank you.
Okay, so another helpful thing you can do on both LAN and WAN is to look at ARP requests. So these are typically going to be requests by devices to find out the location of others, layer 2. So you can examine network floods that are common. That'll be on the LAN side. You can resolve duplicate IPs, which is going to be on the LAN side or the WAN side. And then your ARP spoofing and ARP poisoning typically happen on the LAN by a compromised host. So we're just going to take a look to see what's visible when we try to do a packet capture for ARP on the WAN. So we're going to come back over to our home page. We're going to kill this trace right here. And we're simply going to do ARP as the BPF syntax, Berkeley Packet Filter Syntax. Now, typically, you're going to see a lot of traffic, especially on ISP networks that are dynamic, where they're mostly residential, where you're going to see a lot of ARP traffic because it's very busy. Sometimes there's a misconfiguration by your ISP, and you will see so much ARP traffic, it'll blow your mind. And oftentimes, this is what you see when you see red traffic being blocked on the graph on the system status page. It's very commonly ARP traffic that has nothing to do with anything behind the firewall. It's strictly in the ISP's network, and we just drop that traffic. Sometimes the volume is just really unbelievable. Not so much here, but we've seen it be pretty bad.
So as we're coming to a close, we've done all of our live demos, and I want to thank Warren for helping out with the live demos that we have. We did want to remind you that our online portal is at online.calyptix.com. This is where we're going to post this webinar, and all of our other webinars are posted there as well. You can find out good information from our training resources. Our online handbook is on the online portal. If you don't have access to the online portal, please email support@calyptix.com, and once we verify your information, we can give you access to the online portal. This is one of our basic troubleshooting skill places that we have. So we want to thank you for using that as well. And we try to put as much information as we can here so that you as a partner, as a customer, can go and look up that information. And we want to say thank you to all who have come for our packet analyzer, the first installment. We will have others. We want to see if you had any questions, you can fill them out on our questionnaire, and we'll try to answer your questions. And I think the first one was from Michael. Is this being recorded? And yes, it is being recorded, and we're going to have it on our online portal. Joseph is going to help out with that process to have it up there as quickly as possible. The URL for the change name URL is actually on our public-facing webpage, and it would be www.calyptix.com/change site name. And we can show you that slide again. It'll be at the front of our slides, and we'll try to get back to that as quickly as we can.
Yeah, we'll do it this way.
That's easier. Yes.
Dwayne, thank you guys. It was a lot of great information, a lot of very practical application of the tools that are in AccessEnforcer. that you guys use every day. Oftentimes, I think you've shown that you'll put the screens up if you're doing a WAN and LAN concurrently to sort of see that traffic flow.
Yes.
And you, what is your plan? Y'all are going to work with Joseph and sort of break some of this content up into smaller pieces. Is that right?
Yes, the main purpose of the webinar not only is to give you the information, but to have short videos, video clips that we can have, and we'll have that posted on our YouTube. If you get the opportunity, please subscribe to our YouTube channel as well. We put it on our Twitter, and we're going to put these on our online portal so that we can make sure that you have smaller content that we have from this webinar in a short condensed part of it. So you'll see the IPsec, or you'll definitely see the RDP, because a lot of our partners and clients have issues with that one. So we'll have that broken down, and we'll have that for you guys.
And then in terms of the webinar content, like the presentation we did on the Community Shield and the other 5.0.3 improvements, that's also there in that same YouTube channel and in the portal, right?
That's right.
Yes, yes, it is.
One of those, I wanted to give a brief business update on one of the topics that we talked about during that last session, and I know everybody's familiar with, and that's the supply chain constraints. I've spent the last 10 days working with our team and our vendor partners to line up our inventory really for the next 6 months, and think we're pretty solid. We've obviously had to incur some air freight shipping costs to be in a position to have a reasonable amount of inventory. And so we feel pretty good. If you do have clients that need, hardware upgrades, I would encourage you to start those conversations sooner than later. In those conversations, whether or not it's Calyptix or desktops or servers, hardware is going to be difficult to come by for a while, and having to buy it when you need it may not be ideal. So being prepared to do some planned replacement sooner is better. And I'll remind you guys, the tenets of cybersecurity: confidentiality, integrity, availability. If you don't have the hardware to power the systems, your technology is not available. And at that point, all that investment and dependence they have, whether it's the cloud, whether it's an in-house server, virtualization, they're going to be really in a tough spot. So engage them earlier. Don't wait till December, and think 6 months to 12 months out. In the conversation I've had, the one manufacturer, Taiwanese manufacturer, they say they quote unquote normally operate at 80%, and they quoted me at operating currently at 50%, and I imagine they're probably more like 40% or less, and that's due to the continued shortage in the chips, and those are hitting everybody. It's more impactful, I think, on the lower cost items. And what we're seeing vendors do is force people to higher cost pieces of equipment. Just if you don't want to go buy a new truck, the stripped down model's not available. You got to get the Ford Deluxe 150, King Ranch version, right? So one way, if they're going to sell a unit, they're going to push the higher price unit if there's anything. And so we're seeing a lot of that transition to that. We're also seeing continued delays on even ground freight from the West Coast to the East Coast, even if it can get in the harbor. And we don't see that resolving any time, in our world near term. So that's not while I want to sell more and get you guys to buy the new hardware that we're getting ready to announce that we do have on stock, I really think you need to be thinking forward for your businesses, because we are sensitive to the pricing that folks have, and the availability and the dependency that our clients have on the technology.
Okay, we had a couple other clients that we wanted to, a couple other questions that we wanted to get to. So
yep.
Appreciate all of that information. There was a question from Tom Ogilville. RDP through VPN client visible in the packet analyzer. Yes, you can see in the packet analyzer, if you go to, and we're not going to go there now, but if you went to Home Diagnostics Packet Analyzer, there's a drop down for the Calyptix VPN client. In that VPN client, you will see which internal 10.64.0.0 machine is using port 3389. So you will be able to see that information as well. Another question we have is,
Dwayne, on that one, can I ask you a clarifying question?
please.
So if I'm understanding it right, you would, on the WAN side, you could see the VPN connection on a packet capture on the WAN. And then on the LAN side, you would see what, both the VPN internal client I assigned to that remote machine, as well as the RDP traffic then on the LAN side?
So to break it down, on the WAN side, we would have to look for, as Warren said earlier, UDP port 1194. That'll give you the public IP address that is using UDP port 1194, which is our Calyptix VPN client. Then once we do the drop down in the menu, you will have the Calyptix VPN that you can look at. Then you will see internal IPs, the 10.64 of the client going to an internal IP address on 3389. So on the WAN side, yes, Ben, you would see that traffic, but you would only see the public IPs that are using it. On the Calyptix VPN, we will see the private IP that it's going to and the client number that's using it, 10.64.0.18 or 20.
Okay, so that's helpful. Thank you.
Yes, wonderful. Ken Schaefer sent in something.
Wants to know if he sees all the ARP traffic, is there anything he can do about it? Well, the honest answer is not really. That's not something we have control over. That's on the ISP side. It comes about by their the way they configure their network to be. So I don't think you're really going to get a level 3 tech that can commit to changing a configuration for the ISP. So there's not much that can be done about that.
Yeah, on the WAN side. On the LAN side, ironically enough, if you see ARP traffic on your LAN side, it could be a machine that is having major difficulties. So if one machine is over and over again asking to ARP, it should not be asking every single time. Its ARP table should be populating and something could be wrong with that device. But on the WAN side, like Warren said, I don't think it's too much we can do about that one. We just see it and know that it is clogging up your network, because any traffic that we have to report on is going to be using some packets to get from one side to the other.
Ken further asks, how did we know that IP address was associated with Google? Well, we do enough troubleshooting that we kind of have a good idea of Google's IP ranges that they use. And so that one stood out to us. That's kind of how we know, through experience.
Yeah, a lot of it. Now, one thing that we did is we limited our traffic to that internal IP address, the 192.168.21.107, but we also did it to port 443. So we knew for a fact when Warren was going to open up a packet, when he was going to open up a browser and he clicked the refresh, that's the only site that we were sitting on as well. So if you were to put in anything else, the majority of what's in the packet capture, that's where it's going to be going. So we've narrowed it down, and Warren showed you how to narrow down traffic so that you can see as little as possible. Then once you start the browser, you'll see the traffic of where it's going. And the first site that we went to was Google. So we knew that that's 64. And like Warren said, we know anytime you see 40.97, you're going to Office 365. Anytime you see 64.233, we know we're going to Google. When you see 3113, we know we're going to Facebook. We just see it so many times. It's like looking at a matrix. We can see and know numbers and know exactly where they're going.
And then as a final tip for the people still left on, one of the things we recommend when you're trying to troubleshoot a website or one particular thing is to try to quiet your machine as much as you can. Try to close down extraneous browser tabs that aren't being used, close your email client, close other stuff that's just sitting there. That way you can, better restrict, and you have fewer IP addresses with which to contend with.
Wonderful, wonderful. And we want to thank you all again for coming out to this support webinar, which doesn't happen very often. Generally, we're selling you something, but we just wanted to give you as much information as we can and as many tips as we can to help you. Ben, anything else before we close out?
No, I want to thank you guys for putting the content together, and I want to share in front of our tremendous audience here how much we appreciate Dwayne and Warren and what they do for Calyptix, and each of you guys. I would be remiss if I didn't acknowledge the numerous times that our partners share with us how strong our support is, and Dwayne and Warren work hard to understand y'all's challenges and help you address them, be your technical advocates, and we really enjoy that. And so, thanks for sending us those messages and giving us that support. Our team really thrives with that feedback, and want to let you know that your participation today is indicative of that support, and we thank you very much for it. So,
thank you all. Take care. We'll see you the next time.
Muted.